this video, we are going to describe the formation of line spectrum of hydrogen atom and illustrate the formation of Lyman, Balmer, Paschen, Brackett, and Fan series. First of all, what is a line spectrum? A line spectrum is a spectrum consists of discontinuous and discrete lines produced by excited atoms and ions as the electrons fall back to a lower energy level. Formation of line spectrum in hydrogen atom. Do you recall the four Bohr's atomic postulate? The fourth postulate is electron at its excited state is unstable. It will fall back to lower energy level and release a specific amount of energy in the form of light. The energy of the photon equals to the energy difference between the excited and ground states. The photon emitted is only at a specific wavelength or frequency. Each photon corresponds to a single line in line spectrum. The instrument used to produce line spectrum of hydrogen atom is shown below. In a discharge tube with millions of hydrogen atoms, each atom is promoted to various excited states. When they fall back, they will emit photon which will be separated by a prism into its component. Each component is focused at a definite position according to its wavelength and forms as an image, which is the line spectrum, on the photographic plate. There are several emission series of lines formed when the electrons in hydrogen atoms make a transition from excited state to ground state. The emission series are Lyman, Balmer, Paschen, Brackett, and Fan. Each series has different ground state, N1. As for excited state, it must be greater than N1. For example, in Brackett series, the ground state N1 is N equal to 4. Hence, the excited state N2 must be greater than 4. We should also know where the series lies in spectrum region. Lyman series can be found in ultraviolet regions. Balmer can be found in visible region, while Paschen, Brackett, and Fan series are found in infrared region. The emission series can be described using energy level diagram. The ground states for Lyman series is N equal to 1. So, the lines in Lyman series are formed when electron at excited states falls back to N equal to 1. As for Balmer series, the ground state is N equal to 2. So, the lines in Balmer series are formed when electron at excited states falls back to N equal to 2. In Paschen series, the ground state is N equal to 3. So, the lines in Paschen series are formed when electron at excited states falls back to N equal to 3. Same goes for Brackett series and Fan series. The lines in Brackett series are formed when electron at excited state falls back to N equal to 4, while in Fan series, the lines are formed when electron at excited state falls back to n equal to 5. Here is the quick fact you must know. The first line must be from n plus 1 to n1, which is the ground state. For example, in Lyman series, the ground state is n equal to 1. So, the first line in Lyman series is formed from the transition of electron at n2 to n1. The relationship between line spectrum and energy level diagram is shown below. For example, in Balmer series, the first line in Balmer series is from n equal to 3 to n equal to 2. The second line is from n equal to 4 to n equal to 2. The first line corresponds to the farthest line on the line spectrum, which is the pink one. The second line corresponds to the green one, and so on. Here is another fact you must know. As the line in the line spectrum get closer to each other, the energy will increase and the wavelength will decrease. Example. The following diagram shows the line spectrum of hydrogen atom. Line A is the first line of the Lyman series. Which of the line that corresponds to the shortest wavelength? As we can see on the line spectrum above, from A to E, the wavelength will decrease. So the answer is line E. Next, which of the line that correspond to the lowest frequency? And again, as we can see on the line spectrum above, from A to E, frequency will increase. So the answer for this question is line A. Lastly, draw the energy level diagram for corresponding line spectrum above. First of all, we draw the axis. Make sure the gap between n is getting smaller to show the difference in energy. As we have learned before, the first line is the line that is farthest from the other lines, which in this line spectrum is line A. Since this is Lyman series, the first line is the transition from n equal to 2 to n equals to 1. This is line A, followed by line B, line C, line D, and line E. That's all for the formation of line spectrum of hydrogen atom and the formation of Lyman, Balmer, Paschen, Brackett, and Fan series. Before we end this video, there are two things to remember. When you draw energy level diagram, make sure the gap between n is getting smaller. And secondly, the first line on the line spectrum is the farthest one. That's all. Thank you.